Hey guys, this is going to be the Unit 1A review video. I'm going to work all of these out on virtually a sheet of notebook paper. So hopefully you can use this as an example of how you should be organizing your work in your spiral notebook. Okay, so let's see. We've got number 1 on the review is negative 10 x to the 4th y times negative 4 x to the 5th y squared. Alright, so we're multiplying. So when you multiply, you're going to multiply any coefficients you have. That's going to give me 40, positive 40, and add the exponents. So we're going to have x to the 4 plus 5, which is 9, and y to the 1 plus 2, which is y cubed. And that's your answer. Okay, number 2. We've got 27x to the 13 over 3x cubed. You're going to reduce the fraction first. Okay, so 27 over 3 reduces to give me 9. And when you're dividing, you're going to subtract your exponents. 13 minus 3 is 10, so this is x to the power of 10. All right, number 3. The question says, simplify the exponential expression. It is negative 7 to the power of 0. We have to be extremely careful on this one because we tend to just say, oh, it's like negative 7 all raised to the power of 0. But it's not. If there are not parentheses there, then only the 7 is being raised to the 0. And not the negative. Kind of a confusing concept to get at first. So this is actually negative 1 times 7 to the 0. We know anything to the 0 is 1, so this is going to be negative 1. Okay, so be careful on that. Anytime you've got an exponent next to something that's not in parentheses, it only applies to what it's right next to. So that could also apply to like 2x cubed. It's the same idea. That 3 only applies to the x and not to the 2. But now if I put parentheses around it, the 3 does apply to the 2, and this would be 8x cubed. Same idea. And so just to emphasize, that applies to negatives as well. It only applies to the negative if it's inside parentheses. All right, number 4. Okay, let me write this one out. Negative 45 x to the 9th, y to the 5th, over 9 x to the 4th, y squared, all to the power of 0. Alright, so we know anything to the power of 0 equals 1. So yes, your answer is 1 here. Maybe you want to practice simplifying what's inside though. If you did do that, you would get a negative 5, reducing that fraction, negative 5, x to the 5th, y cubed, if you did simplify what's inside. But regardless, it's raised to the power of 0, so that equals 1. Number 5, got 2 cubed times 2 to the negative 4. When we have like bases and we're multiplying, we're going to add the exponent, so that's 2 to the negative 1. A negative exponent makes me move it to the denominator or get the reciprocal, so that's going to be 1/2. Okay, number 6. Number 6, I've got x to the negative 5, x squared. Same idea here, exact same idea. Whoa. Got something on my screen. So we're multiplying. We're going to add the exponent. That's x to the negative 3. So 1 over x cubed. Negative exponent moves it to the denominator. Okay, so those questions are pretty much the same. Number 7. I've got x to the negative 4 over y to the negative 4. Okay, those negative exponents, I just want to move anything with the negative exponent to the other side of the fraction. So moving the y up gives me y to the 4. Moving the x down, x to the 4. There's nothing else you can do there because the bases don't match. So you're just going to leave it like that. Don't know what's going on here. Okay, number 8. All right, so squaring this, you're just going to distribute that exponent to everything inside. So that's negative 6 squared. X to the 3 times 2, y to the 6 times 2. Negative 6 squared is 36. X to the 6, y to the 12. Number 9. Okay, you got a couple of options here. I'll show you how I would do it, but as long as you get the same answer, you are correct, right? So I would distribute this exponent here, which gives me x to the, remember when you have a power to a power, you multiply, so that's going to be x to the 8, y to the negative 10. Anything with a negative exponent gets moved to the denominator. So that's x8 over y10. Now, there are other routes you could take, and you would get the same answer as long as you don't make any mistakes. Okay, my screen seems to have a problem today. Okay, number 10. X over 9 cubed. X cubed over, and here's where I don't mind you using your calculator, of course. 9 to the power of 3 is 729. That's it. All right, number 11. On a problem like this, I would always look for something to be able to be simplified inside the parentheses first. On this one, there's not anything that you could simplify, but if there were an x on top and bottom, you would want to reduce that first. Okay, so now I'm just going to distribute the exponent. So I have 4 cubed, which is 64. I have x squared cubed. You multiply the two exponents, so that's x6. Multiply the two exponents, that's 9. Multiply the 4 and the 3 here, 12. So that 3 needs to apply to everything. Make sure that you actually cube the 4, not multiply it by 3. And that you multiply all of your exponents. All right, number 12. X negative 2 over y6 to the negative 4. Just like with all of these problems, there are a couple of options here. One thing we've talked about in class is to make this exponent positive, to make that negative 4 into a positive 4. you can just get the reciprocal of the base or flip the base. So make that y to the 6 over x to the negative 2. And that becomes positive 4. Okay, from there, you can distribute the exponent inside. That will be y to the 24 and x to the negative 8. And the last thing would be to bring the x to the numerator and make that exponent positive. Okay. Number 13, got scientific notation. Hopefully these questions are guaranteed correct ones. Hopefully. Just make sure you count correctly and you'll be good. Alright, it's telling us to move the decimal to the left 6 places, right? Because this is actually dividing by 10 6 times. So it's going to make the number smaller. It's going to move the decimal to the left, 6. So that's going to be a 0.00002408. Okay, so I need 5 zeros before the 2. Oops, don't know where that came from. All right, number 14. This time we're moving the decimal the other direction. Positive exponent. Okay, think about it. If you multiply something by 10 7 times, it's going to get larger, right? So the decimal needs to move to the right 7 times. So this is going to give me negative 40032 and 3 more zeros. All right. 15 and 16. We're going the other direction. Got 290,000. And I want to write that in scientific notation. Your decimal needs to go after the first non-zero digit. So that's right here. And so count how many places that moved. 1, 2, 3, 4, 5. 2.9 times 10 to the positive 5. Since we want this number to get larger, right? We want to multiply it by 10 to get 290,000. Multiply it by 10 over and over until you get 290,000. Okay, number 16. 5,002,3260. All right, same exact question. Should have had one where the decimal moved the other direction, but nonetheless, here we are. 5.02326 times 10 to the 1, 2, 3, 4, 5, 6. All right, so just counting how many places you moved. And number 17, getting into our radicals here. I think this is what we need the most work on. So hopefully this helps. All right, to simplify this, we want to use our factor tree to break down the 98. You could divide it by whatever comes to mind that divides into 98, but I'm going to start with 2. Because it's an even number, and that's easy. That is 2 and 49. 49 breaks down into 7 and 7. In order to come out of a square root, you have to have 2 of them. So you get to take a 7 out, but this 2 must stay inside. Look, I have 2 x's, so that means that x gets to come out. The way I taught it in class is that you divide your index, which in this case, because it's a square root, is 2. You take that index and you divide it into the exponent. 2 goes into 2 once, so I can take one x out, and there are none left over, so no x's go inside. That'll work every time. All right, number 18. Square root of 14x squared times the square root of 28x. Okay, when you're multiplying radicals, you multiply outside with outside, inside with inside. This time we only have inside, so we're just going to multiply 14 and 28. But I'm going to leave them separate because my next step is going to be to factor them, right, using my factor tree. Okay, so I've got 4 and 7, 2 and 7, 7 and 4, 4 is 2 and 2. All right, again, to come out of a square root, you need 2 of them. So I've got 2 2s and 2 7s, but I have one more 2 left over, so that guy is going to stay inside. So I get to take a 7 and a 2 out, that's 14. And a 2 stays inside. Now look at your x. Your index 2 goes into 3 one time, and then there's 1 left over. So 14x square root of 2x. All right. Not much room there, so I'm going to go ahead and go to a new page. All right, number 19. Got the square root of 72x cubed over the square root of 2x. Okay, so this one, remember, we've gone over this several times. Because the top and the bottom are both inside of a square root, this is the same as the square root of 72x cubed over 2x. Okay, so you can actually reduce that fraction before you take the square root of anything. Okay, you don't have to rewrite it like this, but you can if that makes more sense. Okay, so 72 over 2 gives me 36. X cubed over x, subtract 3 minus 1, x squared. Square root of 36x squared is 6x. So now moving on to number 20. We've got some addition. We've got 6 square root of 3x plus 8 square root of 3x. Oops, sorry. All right, so look inside the radicals. You've got 3x and 3x on both of them. That means they're like terms, so you can actually add them together. You're just going to add the coefficients. 6 plus 8 is 14, and then the 3x stays inside, so 14 square root of 3x. Okay, let's write this one down. -9 square root of 75 plus 6 square root of 147. Oops, minus 3 square root of 192. All right, so we need to simplify all three of these radicals, and then any like terms that we have, we can combine. On 75, I notice off the bat that's divisible by 25, which is a perfect square. So I like to go ahead and get that one out since I noticed it. So I'm taking a 5 out. I need to multiply it with the -9 that's already there. This 3 is going to stay inside. Okay, 147. I know that's divisible by 3 because all the digits add up to something divisible by 3. So it's 3 and 49. 49 is 7 and 7. Okay, so a 7 comes out, multiplies with the 6 that's already there, and a 3 stays inside. 192. Again, I can tell that's divisible by 3 because 9 plus 2 plus 1 is 12, and that's divisible by 3. That's a rule that if the digits add up to something divisible by 3, then the number itself is divisible by 3. Okay, so this is 64, and 64 gives me 8 and 8. So I can take an 8 out, multiply it with the 3 that's already there, and 3 stays inside. All right, so these are all like terms. They all have square root of 3. So just add the coefficients together. You should get negative 27. Okay, add the 3 coefficients and then square root of 3. Okay, moving on to 22. We've got the cube roots, some more addition, subtraction, but this time cube root. I did have to adjust this one a moment ago. There wasn't a typo, so if your problem doesn't say 432 right here, then you must have started this before I adjusted that, so I'm sorry about that. Okay, so breaking down the 128, that's divisible by 2, that's 64, and 64 we know is 8 and 8, but actually, hopefully, we are getting familiar with our perfect cubes, and we know this is 4 and 16, which is 4 and 4. Either way, you're going to get 4 eventually, but it's easier to break it down this way instead of going all the way to the 2's. So since I have 3 4's here, I can take a 4 out, and then this 2 stays inside. Okay, now with our variables, you're going to say 3 goes into 4 one time, so I can take 1x out, and there is 1 left over. 3 does not go into 2, so both of my y's are going to stay inside. Just dividing this 3 into the exponents to see how many you can take out. Let's try that again. On the second one, let's break down the 432. It's divisible by 2. That's 2, 1, oh, that's not right. It's 216. Okay, and that's 2 and 108. 2 and 54, 2 and 27, that's 3 and 9, 3 and 3. Okay, so break that one all the way down. Okay, things have to come out in groups of 3. So I've got 3 2's and 3 3's. So I can take a 6 out. That's 2 times 3 gives me 6. And then this other 2 needs to stay inside. 3 goes into 4 one time with 1 left over. 3 does not go into 2, so it's just going to stay y squared. Okay, now we want to combine like terms. We're looking at these 2 terms that we have here. Don't forget there was a minus in front of this. Okay, I'm going to go ahead and just rewrite this next to the other one. 4x cube root 2xy squared, and then we have a minus 6x. Okay, notice that those are like terms. They both have the cube root of 2xy squared. So we're going to add the 2 coefficients. 4x minus 6x is negative 2x. Got cube root of 2xy squared. Okay, so add the 2 coefficients, keep the radical the same. Quite a bit of work on that one, but very doable. All right, next one, number 23. right, we want to rationalize the denominator. Remember, to do that for square roots, you can simply multiply by the radical that's in the denominator. Okay, remember the square root of 29 times the square root of 29 is the square root of 29 squared. Square roots and squares cancel, so you're just left with 29. That's that. To rationalize a denominator that has two terms in the denominator, you need to multiply by what's called the conjugate. The conjugate is where you're just going to change this sign in the middle here. So that becomes 7 plus the square root of 2. You're going to multiply by that conjugate on the top and the bottom. In the numerator, you're going to need to distribute the 3. Just distribute the 3 here. So that's 21 plus 3 square root of 2. In the bottom, you're going to need to FOIL. Okay, so be careful here. 7, remember, FOILing is just distributing twice. So you're taking this 7, distributing it to the 7, that's 49. Distributing it to the square root of 2, just 7 square root of 2. Okay, now distribute the negative 2. Negative square root of 2. That gives me minus 7 square root of 2, minus square root of 4. Or you can just, square root of 4 is 2. Okay. Now let's simplify. This always happens when you multiply by a conjugate. That's kind of the whole point of doing it, is that these terms that have a square root are going to cancel. So those are always going to go away. In the top, I can't simplify that. I've got 21 plus 3 square root of 2. In the bottom, I've got 49 minus 2, which is 47. And I cannot simplify that. 21, 3, and 47 are not divisible by the same number. So that's the final answer. The cube root of negative 27 is just negative 3, because negative 3 cubed is negative 27. If you wanted to, you could break this down, 3 and 9, 3 and 3. So you see there are 3 3's to take out, and then don't forget about the negative on the 27. Okay, so not much to that one. 26. I've got the cube root of x to the 5th. So you're just saying 3 goes into 5 once with 2 left over. So x squared stays inside. Okay, number 27. Negative 9 to the 1/2. All right, be careful here. There are no parentheses, so that 1/2 only applies to the 9. So this can be rewritten as negative square root of 9. So negative 3. Be careful on that one. 28. I've got 8 to the negative 4/3. Okay, this is a negative exponent, so let's go ahead and move that 8 to the denominator. So 1 over 8. You could either put the 4/3 like right here, or you could put it in the bottom with the 8. It doesn't matter either way. Just make sure you don't flip the exponent. You never flip the exponent, always flip the base if you're trying to get rid of that negative. Okay, so now this is we're going to change this to a radical. The denominator is a 3, so that's cube root of 8 to the 4th. Remember, it's power over root, so the root is 3 and the exponent is 4. I don't know why I'm writing this out all sideways like this. The cube root of 8 is 2, so it's 1 over 2. 2 to the 4 is 16, so 1 over 16. 29. 6x to the 1/3 times 3x to the 3/2. All right, we're multiplying. So this is just like the first problem we did. You're multiplying. You want to multiply the coefficients and add the exponents. I've got 1/3 plus 3/2 off to the side. Okay, get a common denominator. That gives me 2/6 plus 9/6 gives me 11/6. Okay, so x to the 11 over 6. And the last problem, number 30. Got 81. Whoa. My computer's getting tired. 81 x to the 10 y to the 4 all raised to the 1/2. Okay, remember that exponent 1/2 is the same thing as the square root, so I can rewrite this if my computer will let me. Okay, the square root of 81 is 9. 2 goes into 10 twice, so that's x to the 5. And 2 goes into 4 twice, so that's y squared. You could have also gotten those two exponents by actually distributing the 1/2. Remember, power to a power gets multiplied. So that's 10 times 1/2 is 5, and 4 times 1/2 is 2. So you get the same thing either way. That's math. All right, so I hope you guys, I hope this helped you guys. If you have any questions, please ask, and I hope you guys do well in the test.